So it's a larger turnout than I expected, and that's good. Hopefully I don't embarrass myself too much. So I'm just going to give you an introduction to Titanium, and we're going to get through and get some demos done at the end. So some real code is coming, but I do have a lot of slides to get through before that. So feel free to interrupt me at any point at all in this. Just stick your hand up, shout at me, whatever you like, and I'll try and answer your questions. I don't mind being interrupted. I encourage it. So, I found the silliest picture I could of myself. I'm primarily a PHP developer, and I have been for about 11 years. I work on the CakePHP framework, if anyone's heard of that. It's one of the largest PHP frameworks available. I speak generally about open source, so any technology I find interesting and I can get my hands on, I'll try and get out there and talk to people about it. And you'll see my name pop up on a few conferences around the place. I love developing and I love teaching. I used to teach at Newcastle University on web development and operating systems, and I just love to share my knowledge with people. And it helps me learn, it helps other people learn, and it's a good way to get to meet people. Some information here which I'll throw up at the end if you want to grab me. So Twitter and a website, and CakeDC is the company that I work for at the moment. So I want to talk a little bit about the rise of mobile and how application development became so important to us. So making and distributing applications, mobile applications for money can be a lucrative business if you have the right app idea or if you have the right marketing. Well-designed apps are actively sought after. You get a lot of social and media attention if you have a really well-designed and easy-to-use application. It doesn't matter what it does and how it works a lot of the time, as long as it's clean and easy to use and it makes sense to the user. A good example of that is the application called Color, if anyone's heard of that, which was a big flop in the end but had a massive uptake. It was really easy to use. It was a photo sharing, social networking service, and people took it up because it was an innovative user interface and very easy to use. What I'm finding is that users and customers prefer a product or a service if it's got a mobile counterpart or a mobile element to it. So if they know that they can take a mobile application to access data that they've stored on your website or through some service that you're offering, whether or not they use that mobile service, it's one of those selling points to get them onto using your service. The metrics between what people use in terms of the mobile apps tied with services, I'm not sure, but it's definitely a good selling point. And generally with mobile, you've got you become more available, accessible, and allow for offline usage of services. So one of the benefits you can offer if you've got software as a service. I better check that mine's on silent. Yep. So it offers offline capabilities where otherwise you may not be able to offer that. If you've got a pure web-only application that you're serving a website as your mobile application, people can't access that offline. Whereas building an application that installs onto the device allows you to provide that offline capability. A bit of the history, we've had mobile applications for a long time. Back when PDAs were huge and everyone needed to carry around these giant things in their pockets. The date that comes to mind is one of Apple's PDAs back in 1993. But I'm not sure of the entire history around PDAs, but they've certainly been around for a long time and have provided for application development. The original netbooks, and I'm not talking about small laptops that you get now, but the original netbooks, things that Microsoft sort of helped pioneer. The Symbian era was around when Nokia phones were almost all you could find for mobile phones. When they sort of started to emerge into smartphones, there was a lot of Java development on the Symbian platform. Anyone that's been through that, I feel your pain. Has anyone heard of iMode? Yeah, that was supposed to be this big, huge, awesome thing, and it is big, huge, and awesome still in Japan, but it's fairly well separated and it stays pretty much in Japan, not very popular anywhere else. Has anyone built WAP applications? Yeah, that's not fun either, is it? It's kind of like a card file system where you define like a card or a slide for a page. It worked, and it had its ups and downs, but I think it stands for Wireless Access Protocol. I can't remember from the top of my head. Java ME, it's the mobile edition of Java. A lot of applications and platforms started supporting that, made it very easy for Java developers to do it. As easy as Java can be, that is. And then we start getting into the current generation of smartphones and smart devices, Android, iOS, Windows Phone, Migo, and there are a lot of other platforms as well. I can't list them all here, but you get the general idea of the current technology and the current devices we have. So generally when you're going to build for mobile, you've got these options. If you want to build for Android, Java's the language you need to use. You build for iOS, Apple's iOS, Objective-C is the language of choice. Windows Phone, you use .NET, and generally that's going to be C#, and the BlackBerry is Java as well. There are techniques that you can use to build different languages onto these platforms yourself, but it's transitioning between different languages and linking between them. Again, not a lot of fun. So the solution here is to provide an abstraction layer. So I'll talk a little bit about what an abstraction layer is and what it means for mobile. So it's pulled straight from Wikipedia. An abstraction layer is a way of hiding the implementation details of a particular set of functionality. And by hiding, it's not removing that functionality from you, but hiding the real implementation and providing you a new interface for development, a common interface that you can use and provides simpler functionality and ease of use. So this is actually a diagram I did up quickly of the Titanium SDK. It's sort of my interpretation of how it works. You've got your application-specific code at the top. You've got the common libraries that Titanium provides, and that is things like around geolocation, maps, anything that you need to use on your device, really. So accelerometer, gestures, and then inside the Titanium SDK, it separates it out onto the various platforms. So Android, iOS, and BlackBerry, it separates out those calls out to device-specific calls. So all you need to deal with is the common library, but you get to use the functionality of all of those platforms. And the endpoint is being able to deploy to each of those devices. So you can see how an abstraction layer makes it simple. You've got one code base. So why would you use an abstraction layer? And what are the reasons, what are the pros and cons? One of the cons is generally you've got a slower bit of code because you've got this SDK sitting in the middle that has its own code execution that needs to run as well as yours. So building an app in Objective-C on iOS directly is probably going to be faster than using any of these tools. But given the right care and the right time, you can optimize your application to run pretty well. And there are different alternatives, and I'll go through the different alternatives for abstraction layers that are available. But it simplifies maintenance. You've only got one code base to work on for 3 devices, instead of saying, we're deploying to Android, iPhone, and Migo. Right? So we've got 3 separate code bases to use. With Java and Objective-C, you can translate between the two for the most part, I guess. The languages are not too dissimilar, but it's a bit of a pain in the butt. You know, if you make a change and a quick change on an iOS product and you forget to port it to Android, and then months later you think, well, I fixed that bug, I remember fixing that bug. But you know, trying to re-inject that code or that fix later down the line might not be as easy as it was before. Quicker development. So again, one code base, many platforms, it's obviously going to be much quicker. It allows you to reuse existing knowledge, and what I mean by that is the languages that you need to use when using an abstraction layer aren't always the same languages that the platform supports. In the case of Titanium, one of the major languages it's using is JavaScript. It's one of the most popular ones, but it also supports Python and Ruby, PHP, and there are also community contributed language support options. There's one for Go, and there's also one for, excuse my language, there's one for brainfuck, if anyone's heard of that. And less retraining. So if you've got web developers, and so you've got websites out there, you've got services, you're already offering those, you've got great web developers that can do HTML, CSS, JavaScript, all that, you can reuse that skill. You don't have to retrain people to use Objective-C. It's just better on the resources. So hopefully I've convinced you that using an abstraction layer is a good thing. What can you use if you want to go down that track? There's a few options for different platforms. Each of them have their own benefits. Some of them have restrictions. So NimbleKit is one that I was introduced to about a year ago. It's iOS only. but it makes writing for iOS very simple. The Adobe PhoneGap product, I may be out of date with my knowledge on this one, so correct me if I'm wrong, but back when I was using it, and I've written a couple of apps with it was essentially a web container. So it would deploy an application with a web view, and you would write everything as just basically websites. So there were speed implications for doing that, but I'm told that PhoneGap has actually come a long way since then, and it's much faster. My experience is that it's a bit slow. Adobe Flex and Flash, which we've just recently heard they're starting to drop support for and starting to push HTML5, which is good for us.
I believe there's an announcement today that you went to an open source community.
Oh, right.
Yeah, I'll let me look that up, but sorry, just to last.
If someone can look that up, that'd be handy to know. But yeah, Adobe has announced that they're pushing it. Sorry?
They have open source Flex.
They have open source Flex? Yeah. Okay. Oh, the platform is open source, yes, for Flex. The builder, I think, that they have is not. Yeah. But the compiler and the platform is open source. If you want to do it in a nice IDE and have it build without writing long command lines, you've got to pay for it. Corona is Android and iOS, and the primary language is Lua. Has anyone got Lua experience? What are you using it for? Okay. I've done some game development with Lua. It's all right. Yeah, it's a bit interesting. There's a product called Row Mobile, and when I was trying to find some information about Row Mobile, it was a little bit confusing, a little bit all over the place. But that's got a few platform supports. And then there's the web options. If you want to deploy a website that is accessible on a mobile, you've got various packages that help you do that quickly. A jQuery mobile, Center Touch. And you can also do just a custom website that is accessible on a mobile. So I'm going to talk primarily about Titanium. That's what we're here about. So, yes, which is free, by the way. So it's completely free. It's also open source. And I'll go into detail a bit more. But before we go anywhere, I'm not going to just talk about Titanium and say that it makes you shit rainbows. It does have its own problems. And we'll go through all of them. But yeah, bit of a disclaimer. I'm going to scare you a bit, and I'm going to try and excite you a bit, and hopefully we get to somewhere fun at the end. So, with the platform being free, it gives you the studio environment. It costs nothing. You have all the tools you need in this in the studio and the SDK that you need to get applications up and running. It's open source, so you can actually view the source, you can contribute to it, you can open tickets if you find issues. It's a very open environment and very active. But what is the catch? Accelerator, the company that makes Titanium, is a company that's trying to make profit. And they've got one of the more interesting open source strategies, I guess, around business, one that I really like. And that is they provide commercial support, premium modules, and custom development around the Titanium platform. So if you want to integrate with a service, you just want it done, you want to get someone else to build a component that you want to use, you can get Accelerator to build it. Or if you're running into problems and you're on deadlines, you can get support from them for money. They're quite good. The other side of that is the community is quite large, but not all the time helpful. If you're on forums or they've got a Q&A site, it can be a little bit brutal. That's all, yeah. And the Accelerator official support for people that are using the free stuff and then don't have commercial support can be a little bit disappointing. That's just from my experience. So we take advantage of existing skills. Web developers are already using JavaScript. Hopefully they're using JavaScript. We can learn by different techniques that Titanium promotes and extend the knowledge of existing developers as well. So you end up with better web developers by providing them access to a framework and a platform like this. So the only difference between JavaScript in general is the Titanium specific stuff. So they don't have to change their JavaScript skills. Key advantages I've kind of gone over. Write once, deploy everywhere, which you really want to do. I never want to implement something more than once. If I have to do it more than once, I'm looking for a way to make it quicker, to redo it. Cut down on maintenance and simplify deployment. It's just a build process in the studio to get your code built and ready to deploy onto the marketplace or the App Store. So this is from the Titanium website. Gives you a bit of an overview of the platform. they've got two different SDKs. They've got Titanium Desktop and Titanium Mobile. So you can actually use this to build desktop applications as well. So you can leverage those existing skills from your developers to build desktop apps. They're very similar. You just see you've got the desktop API and the phone API, and the different bridges to the OS. There's different language support. So we've got JavaScript, Ruby, and Python. They also support PHP for desktop. And if you are a PHP developer, that support has just been fixed recently, so that works again, which is really handy. So the Studio, which I've mentioned, the Studio is an environment built on top of Eclipse. So anyone that's used Eclipse will be very familiar with it. It's a standalone application. Lets you build apps, debug, profile the apps, find out where any issues are, provides things like code hinting, so you don't need to know the API off the top of your head. I know I'm one of those people that heads to APIs all the time. I don't want to keep that information in my head if documentation is available. I can keep other more interesting things in there. Easy device testing, so it integrates with the iOS simulator and the Android emulator. And it simplifies deployment because it packages it up for you. So a bit about the platform, and I talked about PhoneGap, and I think it's one of the biggest competitors at the moment, or biggest alternatives. PhoneGap works a little bit differently. Titanium has this three-step process. So it does a pre-compiler. This pre-compile stage goes through an optimization and analysis. It goes through and actually improves the performance of your code by cutting it down. If you're a little bit, I'm not going to say lazy, but if you are not the best JavaScript developer, if you get it done but it could be written in a more optimal way, the optimizer will fix that up for you, and it won't change the way your application works. It finds and resolves dependencies. That's fairly simple. You're normally including external dependencies. Yep.
Does it tell you what you could do better, or does it just go and do it?
It doesn't tell you what you could do better, but if you do want to know what you can do better, you can use Google's Closure tool, which will optimize the code for you. It's the same process. Yep. So the front-end compiler actually converts some of your code, the code that it can, into native code. And that's one of the key differences. So you're ending up with some of your code running as Objective-C on iOS, and it's running as Java on Android. And the difference there is Objective-C compiled runs much faster than running JavaScript through an interpreter on your device. So what it can convert, it will, but what it can't convert, if there's something that's happening in a dynamic nature that it can't convert or it doesn't understand entirely, it packages a JavaScript engine in there to interpret that code. So you get the best of both worlds. JavaScript for stuff that doesn't convert across, and convert it to native where it can. And the platform compiler is the end of the line. So Xcode and iOS SDK compiles it for that platform, and Java and Android will compile for that platform. So it's that three-step process, really gives you a lot of performance. And that's all automated.
Compile the two platforms at the same time as doing Ruby?
It's two menu options. I just click the two options.
Right.
There is an option to package both of them at the same time.
There's a Python script you can run as well to call the compiler, and that's what I do for an automated build process. I just call the compiler manually, so if you want to automate that. So it's optimizing your code, converting it to native for the device, gets the JS engine, makes it super fast and portable no matter what the code is. So it really is providing a lot of benefits. Okay, so JavaScript. Why is JavaScript important? Because as web developers, I don't know Objective-C, but I know JavaScript, so I can be an app developer. So Titanium is view-driven in that you're focusing on the views and you're working in and around your views primarily, and it is event-based, which makes it a perfect match for JavaScript. It's a similar setup. It is event-based. It has a layered view hierarchy so that one view can have many sub-views. It's very similar to the way that the iOS platform organizes its views. So it's similar for anyone that has looked at or played with iOS at all. Okay, so organizing and building your app, this can look a bit confusing to some people at first, apparently, but I'm just going to show you the separation for the code. So when you create a new project, you end up with the main folder you can work with is resources, and that's where all of your JavaScript, JSS, images, where all of that information goes. It also has a separation for the different platforms. You can see Android and iPhone in there, so it separates out things that are going to be specific for those platforms into separate folders, so just very easy to manage. In the iPhone folder you can see we've got specific backgrounds, so these are the startup images for the iPhone platform. You can see one of them has the 2x, default at 2x. That's for the iPhone 4 with a higher resolution screen. So you provide a higher resolution file so that you're not showing a low resolution that's been blown up a bit. And then you can also customize the icon, whatever you want custom for that platform. And yeah, Android. Anyone that's dealt with Android knows that it's really hard to build for everyone because there's no set resolution, there's no set device size. So you end up with all these different manufacturers with different devices, different sizes, different everything. So you end up with all these different images to support different types. So it's a little bit...
It works pretty easily on the native, when you're building for a native.
If you're providing something like
override the bits that you need to.
Yeah. If you're providing like a static image or something for a startup image, like you can't really see those, but those are startup images, the exact size of the device. Providing something like that to get it to fit different resolution screens if you want it to fill the screen, that's a good example where you do need to provide the custom images for it. Okay, I feel like I've missed a slide or two here. Talking about the code that you need to build for the application and how that works and how it's separated. It provides a code context separation between your different windows. So this is an example of .js, which is the main file that runs your application. We've got a message and a window that opens. In our win1.js, which is the code for our window, you can see it's got a URL called win1.js, so it'll open this when this window opens. The message is not available in that context, so that's just an indication to you that there is a separation. It's almost like a class separation. In the case that you do want global data and configuration, Titanium provides an include mechanism. It's also bundled with require.js. If anyone's dealt with Node.js at all, require is a very, very cool way to just include stuff that you need. You'll see the calls that I'm using are ti.something. This is the Titanium library. You can use Titanium or TI. I just keep it short. Okay. So I'm not going to talk about all the layouts, but the tab layout is one of the more common ones that people can start off with just to get things up and running very easily. It's very easy to build. It's very easy to extend. Very easy to understand. So good common examples, and I've got iOS examples because I have an iPhone, I don't have an Android device. The Twitter application, if you've seen it, Foursquare, Combank, and the phone application. These are the ones with the icons down the bottom and the various options you click through. If there are too many options, you'll normally see a More button on the right. And I'll come up to a point about tabbed applications on different platforms a little bit later. So one window per tab, so you define each window for the tab that it's on. Tabs can open up sub-windows, so you're not stuck with just the windows that you've defined for the tabs. Again, no effort required because it's very simple to understand. So this is an example. So you see we've got two tabs defined. We've got a view there. We've got the Android one, which has the tabs at the top, which is one of the platform differences. This is because we're using native controls for the interface. The Android way of doing it is to put the tabs at the top. That's just their standard. And the iPhone down the bottom. So that's one of the differences. One of the other differences, can anyone else see the other difference in these two? Besides colours and data and whatnot?
The rows and repeating.
Sorry?
Numbers and repeating.
Oh no, that's just data. Yeah.
Do you have less tab options? You know, the two at the bottom of the... Well,
Just data differences. They're from different applications. But the other key difference, I guess, is that the iPhone has a title for the tabs. If you've got tab 1 at the top, whereas the Android platform doesn't have it. So one of the differences that doesn't have the tab. So that's a bit of a problem sometimes. It can be a problem. iOS has tabs at the bottom, Android at the top. iOS has a title, Android doesn't. More than likely, if you're working with a creative director and one of these controlling designer people that we all know and love, they probably want everything to look the same on every platform, everything to look and work the same, which, there are different pools of thought on whether or not that should be the case.
It's sucked for the user.
Yeah.
I know I did an Android app for Air New Zealand, for example, which was clearly written for the iPhone.
Yeah.
Because it had a back button on the top of the screen.
Yeah.
And the one that was on the phone didn't do it.
There you go. So that's a good example where you probably want, or my thought is, my approach is that you probably want to stick with the environment that people are used to. So if they've got an Android device and they're used to tabs at the top and no title and back being a hardware button, then stick with that because that's the user experience they're familiar with. If they're on iPhone, they expect glossy everything and transitions everywhere and all sorts of different things. But if you just use the basics, you'll end up with the native UI for that platform. So yeah, this is what happens when we find platform differences. We run out of happy. There are workarounds. Sorry, just 1 second, guys. My slides are slightly out of order, but that's all right. So there are workarounds for different platforms. You can put in custom code checks to see what platform you're running on and run different code based on that. So in this example, we create a new object called, we check the platform, we create a new object called tab group title. And we've got a custom UI library that I've built, and we create a title. We give it some options, we position it, and then we add it to the current window. Then there's a table in this view as well. We set its position to be the height of the title. So we end up moving everything down so that Android gets a title across the top. So there are ways to do this, and once you get used to it, that's not a lot of code to do, to customize to add a title. But yeah, it depends on what you're doing with your platform, if you've got a custom UI or if you want to go with a native one. This hasn't been built in Titanium, but it's just an interface that I like, where you can actually build this with Titanium, and there's a rip-off example that was on GitHub that's been pulled down by Foursquare, unfortunately, but it showed examples of how to build all of your UI components in code to make them custom, and you could run the same app on iPhone and Android, looked identical on both platforms. But again, that problem you're providing the Android users with an iPhone experience. So it really comes down to what your graphics person is demanding. Okay, in terms of user interface and managing your views, it's generally interface stacking and managing this stack and where you are through the stack. When you're building a custom UI, you need to manage your stack carefully. So in terms of the order in which people go through the application and how they can get back, which can end in incorrect stack management of views. Like I say, hopefully I've gotten you to the scary but exciting stage. It lets you do a lot of cool stuff, but it has its problems, and it's going to have its problems long term if it is dealing with multiple platforms like it is. It does make development easy. You can provide the basic application and then customize from there for platform differences. So test on one and then fix for the other. I'll go through some of the libraries that Titanium provides and some of the abstraction that it provides over the hardware and the simplicity of using it, I guess. So I'm going to run through some of the libraries it has. The accelerometer is, I'm running mostly alphabetical, mostly. The accelerometer lets you tap into the hardware accelerometer, so you can add and remove event listeners. You can also simulate movement on the device by firing one of its events. So a good example is a Titanium lightsaber app. You move your phone around and it makes the lightsaber noises. I spend way too much time using it. So geolocation, just basically current position and address finding. It does forward and reverse geolocation. So you can punch in an address and get coordinates back, or you can put in coordinates and get coordinates, address back, address, get coordinates back. You can go both ways. And again, you can add and remove listeners for different events. The map, this is an example of it on Android, which has a few different options. Common interface to be able to use maps and to be able to provide information to maps, but the view back will be slightly different, but it's UI specific for the device. You can use it in conjunction with the geolocation stuff, so provide the current location of the user and center on that position, maybe find points of interest around there. And it provides all the common stuff like zooming in and out. You've got different map types. You can enable and disable layers. All of that just comes with the ti.map library. One of the cooler things that I've been playing with is the analytics stuff. This is not one of my examples, but it's from a game developer that I know. So using the iPad with Titanium Analytics to get information about what happens in the game. So what he's mapping here, he's heat mapping where people die in the game. So that's really useful information for a few reasons, and you can see that maybe in terms of a game, you really want it to be challenging. You don't want it to be too difficult because you'll deter people, but it needs to be challenging enough so that once they get past a challenge, they've got that rush of, I beat that, I can move on, I can do more. So you could look at this and see that maybe too many people are dying here, so we need to adjust the level so that it's a little bit easier for users to do. And then maybe up here, maybe we need to make that a little bit difficult because people are just breezing past. So the analytics allows you to define custom events and to report on those and receive the information back and generate useful information from it. Which is really important. If you've got a section of your application that you're building out that's got a lot of time and effort being put into it, but your analytics tells you that not a lot of people are going in there, or people are going in there for a second or so and then back out, maybe that's not a feature you should be spending time on. TI.contacts provides a common interface for the contacts for the address book. On the Android, it's actually read-only, so you can actually only read the contacts in to use that information, but iPhone, you can actually write contacts. It provides a database, so this is a SQL-compliant database for local storage. You can provide synchronization between a remote service, and it's really good for handling all of your offline storage. So you can provide a common data structure similar to one that you might have on a web service somewhere, and provide that local database as just a local copy of data. Sync that when they're online. File system, basic read and write. File system. On the iOS, you're restricted to the sandbox your application is in, but that's the case for all iOS apps now. They're all sandboxed. Android allows you to get to the SD cards or whatever they've plugged in for external media. This is really handy. A lot of people use this one for a simple Facebook integration. Allows you to do login to store the authentication so that you can provide a login mechanism for your application just with Facebook without too much code. Just using the Facebook component. It works everywhere and it works everywhere the same. It's very simple to use. Does it feel like a sales pitch yet? So the gesture. So I just want to go through all these libraries just because I want to show you the features. The gesture. When I first looked at the gesture, I thought, oh, cool, I can track touches and different pinch movements and whatnot. But it's just basically hardware gestures, shaking the phone, changing the orientation, that sort of thing. Network, if you're doing anything with a mobile app, it's probably going to be networkable in some way, accessing the internet in some way. Provides TCP, HTTP, and Bonjour clients. You can also start servers for those as well. On top of TCP and HTTP, you can build anything else you like. Anything that's built on top of those protocols, you can implement. We're actually going to run through a network example today. XML is really handy just for grabbing. If you're dealing with a SOAP service or OData, which I'll go through in a little bit, you can produce XML and consume it just in a nice, easy way. One of my personal favourites, and I think this is the last one, is YQL support. Has anyone heard of YQL? Hands up if you've heard, nice and high. It's like 5 people, 6. Who has used it in a real product? No? No one? Okay. That's cool. It does rely on an internet connection, that's one downside, but it allows you to query a lot of services that don't have things like REST services available or an XML feed or anything. You can actually query web pages and then use XPath to get certain sections of it out. So you can scrape websites, but do it responsibly if you do it. There's a link here. I suggest everyone have a look at it. It's very interesting technology. And you basically do an SQL style statement on whatever collection you tell it to query on. A good example is the Lanyard website, which is a conferences social website. It provides a lot of conference information, so I can find out what conferences are in Australia, what's coming up, what's just been on, all of that, but they don't have an API, or they didn't when I was playing with it. So what I did was I put into YQL the web address where I wanted to go that showed the country listing, and did an XPath select on it, and pulled out the countries and the icons, and then threw those into a table view. And then so I've got a nice listing of all the countries, and when I click on that, it passed the country name through to the next view, and it loaded up all the conferences for that country. So I was able to do that through YQL instead of, because they didn't have an API available. So beyond that, there are commercial components. Some are reasonably priced, some are pretty expensive. Depends on who's putting them up for sale. It's not just Appcelerator that has them for sale. There's ones from community members as well. And if you build something that is useful to other people, you feel might be worth some money, you can actually sell your components for Titanium as well. So a nice way to earn some extra money on top of the development you've done. There's a link down here for it as well. These slides will be online. They're actually already online on SlideShare, and I'll provide you the link in a bit. Also, if you're looking for more information around components and things available around Titanium, definitely search GitHub. There's, last night, 706 results for Titanium repositories. There's a couple of really useful ones. There's components and full projects, all sorts of things. There's a lot of gists as well, just code snippets that you can use. There's a short URL for the link to Titanium stuff. But some of the stuff you'll find in Titanium is abstracting Titanium. So they're making Titanium easier to use by providing short calls for debug functions and common UI elements, that sort of thing. Okay, JSS. So I mentioned this earlier. JSS is like a JavaScript style sheet, essentially. I initially had some problems setting this up, and there isn't a lot of information about it. It's very easy to use though, once you know how to use it. Essentially you have an app.js, which defines your application, and you pair it with an app.jss, which defines styles and extra information for your application for that window. You can set almost any property on the ID that you've got. I'll show you a code example in a second. One of the things that you will come across is if you're not cleaning your application, you'll find that the JSS changes you've made won't come through in the app. So if you are using JSS, clean every time before you do a build, before you test. Otherwise you'll get confused. So this is one of the shortest examples you can get to build an app that, that works, I guess. So we create a window, we've got a button, we add the button to the window, and we open the window. That's all we're doing, and all we're setting on the button is an ID. What we do in the app.jss, we reference that ID, similar to CSS, and we set these variables, width, height, bottom, and we're actually also setting the title to contain some text. So we can do more than just style and positioning, that sort of thing. We can actually set some useful information on there, which is really handy. I've got a system that builds in different JSS files based on who is building the application. So you end up with a different theme for different people, different things, localization that people can control themselves, different text in different situations based on who it is. So yeah, the text just goes straight onto the button. So, how are we doing for time? 20 minutes? So, building your application, I will run through this, but when you go to create a new project, a new mobile project, you will end up in this interface, very Eclipse-esque. Basically provide your project name and an app ID, which uniquely identifies the application. Then you just specify what platforms you want to support. When you first start up Titanium, if you've got a Mac and you've got Xcode installed, iPad and iPhone will be available. If you're on Windows, nothing will be available. Android becomes available when you install the Android SDK and configure it in Titanium. You just need to give it the path to go to. With Titanium, with Android, you also need to install SDKs, but all that information is on their documentation. They provide a couple of templates. Some of them are useful. We'll use one today, the tabbed application, and you can also just write it from scratch. So this is in contrast to this example here, which is very small, very minimal, but gets this app built, and it looks half decent. The style I like to use is based on their tabbed example, and it separates your code out. You can see up the top we've got 2 require statements. We're including 2 separate pieces of code that we're going to reuse. We've got a tab group and a window. So we define a tab group to do a certain thing. It creates a tab group and configures it. We can reuse that tab group over and over. Same with the app window. So we're building on top of the Titanium stuff. Okay, so coding montage. We're going to actually try and build something. So the Titanium Studio, it doesn't look great at this resolution, but basically start a new project.
So it's a separate studio.
Sorry?
Yeah, there is no Eclipse option for this. You have to use their studio.
I don't believe there's an Eclipse plugin for it, no.
Okay.
So you can see that the options were to start a desktop application or a mobile application. So this is the screen that pops up. So we've got our project name and an app ID, which generally forms a domain name style. You select the platforms that we want to support, and then I actually want to use the tabbed application template. Actually, what we might do, I might show you just the plain one to start with. So it's generating the project files now to build the application. And you can see we've got this resources folder. Is that okay to see up the back? Yep. We've got the Android and iPhone separation, and we've got app.js, which if we open, I increased the font last night, maybe it's too big. But we create a tab group that creates a window, then creates a tab. In this one, it assigns the window for this tab to be win1, which we created here, the first window. We create a label and add that to the window. So it's you can see all the options here are mostly text, font, align. It's all style stuff we could export to a JSS file. But a good example to get you started. It also creates a second window just for a second tab as an example. And if we run this, if I look nervous, it's because sometimes my iPhone simulator crashes. So what it's doing now is going through the code optimization process. It's going through and linking external libraries that Titanium depends on. It's compiling it for the iPhone, and it's building up a package that it can install onto the iPhone simulator. So it's just a simple click to build it and to run it in the simulator. I do like the Mac platform for its integration, easy to use for the simulator and for these types of tools. If you think this is slow, you should try the Android emulator. For anyone that's tried to use it, it's very slow to boot. Once it's booted, it's not too bad. Okay, so the splash screen that you saw really quickly was one of the files defined in the iPhone folder. So those are provided by default. So we've got 2 tabs, and it looks and feels like it should. Nothing too fancy about that. Now you can see the tab title changes and the window text changes as well. It's very, very basic. And the code to get that done is not very difficult. to go beyond that a bit, I'll start another one. I'm building a giant tabbed application at the moment. It's really quite large, so I do tend to prefer this example. You can see we've got extra stuff here. We've got a UI folder which contains the tab group and the app window. In app.js it looks slightly different. That's the code I showed you before. So it's different functionality. We define a globals object that's available everywhere. And we set the tabs to be a new tab group. We're providing the two tabs, a title icon and a window. The tab group so all it does is it takes arguments, checks the arguments length, and then it loops through and does a ti.ui.createTab. So for this create tab group, it's got all the functionality for creating the tabs for that group just inside this particular object. Makes it very simple and easy to use. So one of the examples I'm going to run through is creating a basic Twitter client for OSDC. So we're going to use the network, we're going to create a little bit of custom UI, and we'll see how we go. I've never done a talk on Titanium before, by the way, so coding live for it is going to be fun. Just going to make this code a bit more readable. It's Eclipse, yes. You don't know where the options are. Does anyone know where I can find font size?
There's colors and fonts and there's tiny fonts.
Oh, colors and fonts. There you go. Does that look alright? Yep. Okay, so we'll use this tabbed example that we've got. We're already including the tab group in the app window. I might just run this example so we can see how it looks, and we'll extend it from here. So think about the design. So it's separated the tab group and the window to simplify functionality. We probably want to do the same thing, but we don't want to create just a window for our next tab, which will be Twitter. We would probably want to create a Twitter window or something that manages Twitter all in one, and we can just use it anywhere. So we'll create a Twitter window, and we'll include it, and then add it as a new tab. All in 10 minutes, hopefully. Okay, so this is the tab example. It's slightly different. Still two tabs, and you've got this stacked notion where you open a new window on top of this tab, and it provides you with the back options naturally. So we're just going to build on top of this. Okay, so we haven't actually written any code for it yet, but that's the require that we need for it. Creating a reference to the Twitter window object. So we now need to go and create that one. Okay. Now I'm going to cheat a little bit. And reference code I wrote before. So when you're dealing with JavaScript, you're generally dealing with exports or globals or some globally defined object that you can pass back for a require option. So require.js uses exports. So if you define something on exports, it will make it available when you're doing a require. What do we got? So what we're going to do is, it needs a return result from this Twitter window. So when we create a new instance, it needs something useful it can use as a return. So we'll create a table view. No. So create a new window and then return that window. That's all it's doing at the moment. And we're just doing a pass-through with the arguments. You can add in a new tab. This L string is for localization. Just going to copy that icon that they've got because I haven't got a custom icon for this. And we're going to specify the new Twitter window that we've got. That will do. Once you've done the first build, as you build again, it makes it much quicker. So the next execution is actually much faster. So we've now got a Twitter tab down the bottom. Doesn't do anything yet, but it's that simple to add a new tab. I'm just told I've got 5 minutes left, so would you prefer I run through this example or try and build it out? We might run through it. Okay, so what I've got here, it is very quick to do. This took me about 10-15 minutes. I store the Twitter URL. That's the start of the URL to do the Twitter search. It's just got a Q equals at the end, and we're going to append what we want to search for. So we've got our window, created a window, and it's called self. We also want to create a table view, and that's the Twitter style, or well, not the Twitter style, but any sort of list that you want to scroll up and down. Table view is very handy for that. We've got a load tweets function, which I'll go through in a second, but we call load tweets, and then we add the table view, and then return. So that's all we're doing, calling load tweets. Load tweets goes through a few things. Creates a client, which is just a HTTP client, using the TI network. Sorry. And then it opens the Twitter URL and appends hash OSDC. The %23 is URL encoded hash. Then we specify an onload function. So when you have loaded that, what code to execute. It goes through and grabs the results, looks at the client's response text, passes it through JSON.parse, which is a JavaScript stand. This JSON object comes with JavaScript. Then we loop through the results. Just do a for loop over the result length. So we grab the tweet, the reference to the tweet, and we start creating the labels that we're going to need. At the top we've got the tweet from, so who is that from? The text is just tweet.fromUser. This is part of the JSON response that Twitter provides. We've got some color and whatnot there. The tweet text itself, so what they've tweeted, different color. And then we've got a view for the tweet itself. Now the view for the tweet itself just provides some padding. It's got top, bottom, left, right, and it's just moving in a little bit so it's separated from the rest. Then to the view that we've created, we just add the from text, or the from label, and the text label. We create a new row to go into the table. This table has many rows. And then we add the view to the row. So we end up with a window which has a table view. Table view has a table view row. And that row has a, what did we create for it? That row just has the tweet view, which is another view with the labels. Run it. pretty. In this example, I've only got 2 tabs, but when we click on it, it loads the tweets as soon as the application starts. We've coloured the thing slightly differently. It provides that padding that we say, 5 pixels in on each thing, and that's very simple to use. And you can see it's very fluid and natural. Someone tweeted it up there just to get themselves on it. So that's a good example of basic network interaction, creating some custom items. These are separate labels. They automatically flow in a left to right, top to down nature. So this just fills the space that it needs to. Same with this. We just coloured it differently. Very simple. Are there any questions on that in the next 2 minutes that we've got?
Could you try and show us the Android emulator?
I can try, but it does take a long time to boot. That's all.
You probably do other questions while it's loading.
Yep. Okay. Other questions? Yes.
Can you use standard JavaScript libraries like jQueries and those sorts of things if you want? Or
You can use things that don't.
JS or
You can use things that don't try and reference the DOM. It doesn't have a traditional DOM, doesn't have a window, doesn't have these things, but yes. So an example that I worked on specifically for you last night, the OData example I wanted to get to, the JavaScript OData library references window for some reason. I don't know why. So I couldn't use that library. So I built my own. But it's very, very simple to do. But yeah, as long as it doesn't reference a browser-specific something.
so it's they call it it's something JavaScript. Forget it. Doesn't matter.
Any other questions? Anything at all?
I can just add that that's the Flex SDK that's being open sourced.
Right.
So
Yes.
you said that if you try and compile the code natively, it can, otherwise you can include JavaScript and terms.
Yeah.
You also try and avoid doing those. Is that easy to do? There's several features that make that happen.
The platform being open source, you can look at how it's going through it. You should probably pull out the part that is doing that conversion and find out what is going But there's no simple analysis tool to see what is that code that is
So does
being
it tell you the past?
Not that I'm aware of, no.
But is it a big problem? Does
Sorry?
it make the code a lot bigger or?
It does make it bigger to include the JavaScript engine, but it doesn't necessarily affect the speed so much. It's not a huge issue. The amount that is left over in JavaScript generally for general JavaScript is minimal change.
I think that's all we have time for now. I'm sure Graham will be happy to talk to you. Yep, at the conference. So I'd like you to join me in thanking Graham for a great talk.
I am, yes.
Fantastic. So, thanks for speaking. So we've got some gingerbread coffee and a limited edition stainless steel.
Thank you very much.
Thank you very much.